Welcome to the physics class, BSc, third semester. Paper name Geometrical and Physical Optics, Electricity 1 and Basic Electronics. In this paper, in Unit 3rd, Theory of Dielectrics and Moving Coil Galvanometer, in the 12th session, we learned about moving coil galvanometer and conditions for a moving coil galvanometer to be ballistic and deadbeat. So now we see the definition of the galvanometer. So already we familiar with galvanometers are the instruments primarily used for detecting and measuring electric current, especially small currents or charge current passing for a specific time. It works on the principle that current carrying conductor placed in a magnetic field. It experiences torque. So we are familiar with in your laboratories we can see the galvanometers types. So in the four main types of galvanometers are identified. They are based on the operating principles. Moving iron galvanometer, a soft iron piece moves in a coil's magnetic field. Magnet galvanometer, a magnet moves in a fixed coil's magnetic field. Moving coil galvanometer, string vibration galvanometer, electrodynamometers. These are four types of galvanometers. Next we see moving coil galvanometer or attraction type galvanometer. A piece of soft iron attracted by a fixed solenoid to measuring current with attraction balanced by restoring force, that is gravitational or spring. There are two types of galvanometers for measuring current, that is soft iron repulsion type. Utilization principle of repulsion between soft iron bars A and B placed with a solenoid when a current passes through it. A bar B is fixed while bar A is attached to a pointer that moves over a scale due to the repulsive force balanced by restoring gravitational force or a spring. These instruments are cost effective and suitable for large current and can be used for alternating currents as the repulsion is independent of the current direction. Disadvantage includes low sensitivity to small currents susceptibility to stray magnetic fields and hysteresis effects which can lead inaccurate reading. So second type is moving coil galvanometer. So this moving coil galvanometer already seen in your lab, this one. So the construction of the diagram. So what is the principle it work in moving coil principle means it is based on the Fleming's left hand rule, where a current carrying conductor in a magnetic field experiences force causing moment. So now we can see. So now we can see the visual moving coil galvanometer 1 simulation. Galvanometer deflection, how it can be obtained. Please see in this one. Now you can see another 3D simulation working of moving coil galvanometer. It has a solenoidal. Solenoidal will be connected, is placed into an magnet. How it can be deflection will be obtained by varying current. See this reading. So already seen how it can be working in 3-dimensional moving coil galvanometer. It's working based on the Fleming's left hand rule. While current carrying conductor, a magnetic field experiences force. So construction of this moving coil galvanometer, now we can see. So construction of the moving coil galvanometer is a rectangular coil by and well insulated copper wire suspended. It placed into n pole pieces of the magnet soft iron cylinder. A soft iron cylinder is placed inside of the coil, ensures magnetic field radial and uniform, which enhances the galvanometer sensitivity. A pointer it can be used to attach it to the coil. Allowing for measuring current. So how it can be working already seen. Now we can see some points. When current flows through the coil, it experiences a torque. Coil rotates. A pointer shows the deflection proportional to the current. By current varying, deflection will be seen in that simulation. So this deflection is opposed by a restoring torque of a spring suspension wire leading to an equilibrium condition. So now we see the conditions of the moving coil galvanometer. There are two conditions of the moving coil galvanometer, that is deadbeat or aperiodic galvanometer, which measures the steady current, is characterized by quick response and high damping. Ballistic galvanometer, it measures the quantity of charge, is characterized by free oscillation and low damping. So now we see the condition for moving coil to be a ballistic. So condition for the moving coil galvanometer is to be a ballistic. So ballistic, it's a type of sensitive galvanometer which is used for estimating quantity of charge flow through. It is called ballistic galvanometer. The condition for moving coil galvanometer to be ballistic are as follows: sensitive galvanometer and current flow duration, time period, coil design and suspension. So now we see one by one. Sensitive galvanometer, it is a sensitive galvanometer designed for charge estimation. Sensitive galvanometer is designed for what? Charge estimation. Flow, current flow duration. The current flow in the coil flows only for a short time when measuring the quantity of the charge. So periodic time. The periodic time of the coil T must be greater than delta T, during which charge flows. Since the time period of the coil is given by T is equals to 2 pi into root of I dividing by C. Here I is the moment of inertia and C is restoring couple per unit twist. So now we can see the coil design. To achieve a long time period and minimize damping, the moving part should have a large moment of inertia. The restoring couple per unit twist should be a small, and the coil should be wound over a non-conducting heavy frame like ivory or bamboo. Suspension and air resistance. Air resistance should be minimal and the suspension of the fiber should be very fine. This is the condition for moving coil galvanometer to a ballistic. So now we see the moving coil galvanometer condition for a deadbeat. So deadbeat, it is a device by measuring a small electrical current. It is called deadbeat. The condition for moving galvanometer to be a deadbeat are as follows. Small periodic time. The coil should have a small periodic time of swing, meaning it comes to rest quickly after the current is passed through it. So that time period is T is equals to 2 pi into root of I dividing by C. Here I is the moment of inertia and C is restoring couple per unit twist. The small moment of inertia. The moving part of the coil should possess a small moment of inertia. Large restoring couple per unit twist. The restoring couple per unit twist should be large. The large damping should be as large as possible. Quickly bring the coil to rest without oscillations. Coil construction. The coil is wound over non-magnetic or metallic conducting frame made of thick copper wire and has a smaller number of turns. Thickness of the fiber. The suspension of the fiber should be comparatively thicker. So now we see the differences between the deadbeat and ballistic galvanometer. Deadbeat galvanometer is used for measure the steady current, means constant current. In ballistic galvanometer is used for measures the charge. So deadbeat ballistic galvanometer is used in a metallic frame. It has high damping. It is used for non-metallic. In a ballistic galvanometer has a low damping. Deadbeat galvanometer has a pointer quickly returns to 0. In ballistic galvanometer, pointer oscillates before settling. In deadbeat galvanometer used in an ammeters and voltmeters, it is used. Ballistic galvanometer is used in measuring capacitors, discharge or charge transfer. Thank you for watching this session. In today's class we learned moving galvanometer, types of galvanometer and moving coil galvanometer are conditions for the moving coil to be a ballistic and deadbeat. Thank you.